The problem said a sphere of mass 2 kg, is released from rest. See, it is held horizontally and it is attached to strings. It's sort of pendulum. So sphere of mass 2 kg is released from rest and strikes a block 2.5 kg. This is a block of 2.5 kg resting on horizontal surface. How far the block will move after the impact? Assume E to be 0.75 and the coefficient of friction between the block and the floor is 0.25. Now see what happens in the problem. This, when pendulum is held like this and released, it comes, hits it and gives some velocity to this block, and this moves on. In absence of friction, this would have moved forever, but friction resists it, and at some distance d it stops, and we are asked this distance d. So how we'll do it is we'll break up the problem in two parts. First, this pendulum falling down and hitting, and then this moving. So when this pendulum hits this body, what happens is they have an impact, a direct impact, and we can use our equations m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2, and see, this is the momentum equation. Now we can say that this pendulum has mass m1, this body has mass m2, and they have a direct impact, and there is no external force, so the momentum before the impact and after the impact has to be conserved. Now let's see so we'll put the values. M1 is 2 as given here. U1 is velocity of this pendulum just before it hits the block or hits this body. Now we will be able to work out through this formula, u is equal to root 2 gh, because pendulum has fallen through height of 1.2 meter. Why? Because the string length is 1.2 meters. So essentially it has fallen through height of 1.2 meter, and therefore if you do root 2 g into 1.5, you will get 4.85 meters per second square. Then m2 is mass of this block, which is 2.5, and initially it is at rest, so velocity is 0. Let final velocity of the pendulum be v1 and final velocity of this block or body be v2. Now we have one more equation, that is velocity of separation upon velocity of approach is coefficient of restitution, which is given here. So we can again put the numbers. v2 minus v1, 0 minus 4.85 is equal to 0.75. If we solve these two for v2, which is of interest to us, we'll get v2 as 3.77 meters per second. What it means is that this pendulum has fallen, and due to this collision, this body got velocity of 3.7 meter per second, and now it will start moving in this direction. As I said earlier, if friction was not there, this would have moved forever. But what is going to happen is this kinetic energy due to this velocity is going to be absorbed by the work done by the friction. So if you put it in equation form, what I get is half 2.5 the mass and v square 3.77 square is equal to frictional force mu r. Mu is 0.25 and reaction in this simple case is the weight. So mu r into d is the work done by the frictional force or energy lost in the friction. So that has to be equal to this initial kinetic energy. And if we solve this, we'll get ds 2.9 meter. So what this means is, due to this impact, direct impact, body will move 2.9 meter towards our left. That's what was asked. Look at one more problem, which says figure shows sphere A and B suspended by cords 2.5 meter and 2 meter long respectively. Masses of the spheres A and B are 1.5 kg and 2 kg respectively. Sphere A is pulled to a position A which is 0.5 meter above A, and release from rest. It is held here and then released. What will happen? It will come, hit here, and this pendulum will move like this. See, it will hit and this pendulum will move. And what they have said, that sphere B is at rest when struck by A with direct impact. Now, sphere A and B have direct impact. B was at rest, and due to this impact it got some velocity and it moved up. And what they found is after impact, the sphere B rises through height of 300 mm, that is 0.3 meter, above its lowest point, that is about this point. Determine the coefficient of restitution. So in this collision, with all data given, they want the coefficient of restitution for this impact. So let's do like this. Let's write our conservation of momentum equation for this impact, and let's figure out what is what. Now you see, u is equal to root 2gh formula is going to be handy, because see, sphere A, when it falls through height of 0.5 by root 2gh, we know initial velocity of the sphere that will come to sphere A, that will come to 3.13. So m1 is 1.5, that's the mass of sphere A. Initial velocity just before impact with sphere B, the velocity of sphere A is 3.13 plus m2, that is mass of sphere B, into 0, that is u2, is equal to 1.5 v1 plus mass 2, and v2 value, see how we have got, because we know that because of this velocity it rose to 0.3 meter. So again, using u is equal to root 2gh and putting h is equal to 0.3 this time, if you work out, you will get u2 as 2.426. And then this equation has only one unknown, so we can solve for v1. And we have another equation, velocity of separation upon velocity of approach is equal to minus coefficient of restitution. So these two will enable us to solve for v1 and e. See, from first equation you solve v1, put it in the second, we'll get e as 0.808. Thank you.